So I will be using my robot arm simulator to create a replica of the Puma 560 arm. This arm was built in the 1960s and is still used today as a reference robot arm model. This robot has 6 different joints, 3 in the base over here and 3 located in the wrist. I'll be using the University of Pennsylvania's diagram of the Puma 560 and try to replicate it in my robot arm simulator. So let's start off with the simulator. The first thing that we have to do is we have to add all the joints in here. Now I've done the calculations before just to figure out where all the joints are located, so I'll be inputting the joints over here. The first joint is going to be located at the origin, and this is going to be our first joint. It'll be located at Cartesian location 0, 0, 0, and will be rotating around the z-axis. So we'll input that rotation axis as 0, 0, 1. To help identify joints and make it more clear for the user, I will be using rainbow colors for all the joints. So the first color is red, and we can set it like so. Now we just click the Add Joint button, and you can see over here that we have a joint located at 0, 0, 0. The next joint is located at 0, 0, 3. So we simply change the last parameter to 3. And the rotation axis this time, this joint will be rotating around the y-axis. So we change the rotation axis from 0, 0, 1 to 0, 1, 0. This joint will be colored orange. So as I click these add joints, notice that the second joint is now over here, and a black link has been calculated and connects the first joint and the second joint together. Now I'm going to go create the final 5 other joints for this robot. Okay, now we have a replica of the Puma 560 robotic arm, now modeled on my simulator over here. The purple joint over here denotes the end effector, that is the claw of the robot. And if you look down here, all these sliders, there's 7 of them because there's 7 different joints. Now, each of the sliders corresponds with one of the joints on here, from minus 360 degrees to positive 360 degrees. So for example, this first slider corresponds with the red joint over here, the first one. So you can see that we can rotate, and yes, it is rotating around the z-axis as we specified, back and forth. Orange joint rotates around the y-axis. So you can see the robot arm moves up and moves down. The third joint, the yellow one, also corresponds with the y-axis. So you can see it too moves up and down. The green joint corresponds with the z-axis, so the remaining end effector and the remaining 2 joints will also rotate. Finally, the indigo axis will rotate around the x-axis, and you can see this over here. So the last part of my simulator is the forward kinematics section. And the forward kinematics determines the positions of all the joints with respect to each other. So if the bottom joint rotates, and then the forward kinematics will calculate the Cartesian location of all the other joints, as well as provides the joint angles that each of the joints are at. So for example, you can see that the first joint is currently at the reference minus 46 degrees. And you can see that the number does indeed change as I'm sliding the first joint around. Notice that joints 3 through 7, their x and y locations are also changing, but their z is constant. And this makes sense because we aren't moving in the z direction, we're rotating about it. Likewise, we can control the orange joint with the second slider. Again, notice that because we're rotating around the y-axis, notice that all the positions are changing, and that also makes sense. So with the four kinematics over here, a user can easily determine where all the joints are going to be with respect to each other, as well as with respect to the origin reference frame over here. And this provides an easy to use tool to help new roboticists visualize robotic arms.